how do we make a machine think and act the way humans do? So if a human being is doing a particular task, can I program that into a machine? Can I program the logic into a machine, into a system, or into a computer as we call it today? And that computer will repetitively perform those instructions exactly how we asked it to do it. And this is what led to a specific branch of AI, which is what we refer to as rule-based AI. All of you can see my screen. This is what we refer to as rule-based intelligence, or what we call rule-based AI. That is rule-based AI. So rule-based AI is that kind of AI where you tell the machine what to do and how to do it. You explicitly define the rules, you explicitly define the logic, and you tell the machine explicitly what you do, what you want it to do. I'll give you a very simple example of rule-based AI. Imagine you have your home air conditioner that is on right now, and it is running at 26, 27 degrees Celsius. Let's say your home air conditioner is running at 26, 27 degrees Celsius, 27 degrees Celsius. It is set to auto mode. So what will happen? There is a sensor in the air conditioner that is constantly monitoring your room temperature. If the temperature of your room falls below 26, the AC will stop cooling. Sometimes you hear the compressor stops. When the room gets too cold, the compressor stops. And if your room temperature increases above 26, the compressor automatically starts. No? You will see the fans are whirring, and you'll hear the sound of the AC. Sometimes it stops, sometimes it starts, sometimes it slows down. Right? We have variable compressors also. So what is it? Think about it. It's a kind of an intelligent machine, right? It's a very basic example, but that is how AI came to be in the 1950s. That is how, and that is the inspiration with which this idea was coined. That instead of having a human being control the temperature manually, can I program a set of rules, or can I program an if-else statement? It's like a if-else conditional statement, right? So if the temperature is greater than this, then this will happen, else this will happen. If the temperature is more than the room temperature, right? If the room temperature is more, then the compressor will start, else the compressor will stop. So this is how we think of a rule-based intelligence system, where the rules are predefined. You study the system in detail, you provide the rules, you hard code the rules, and you explicitly tell the machine what to do and what not to do. And this is also how we do traditional programming, right? When you write a computer program, when you write a software, what are you actually doing? A lot of you are software developers. And whenever you write a software program, whenever you write a computer program or a script, what you're doing is exactly this. In a way, you're doing exactly this. You're giving a set of rules, and you're telling the machine what to do and how to do it. Isn't it? You study the instruction, you study the system specifications, and you explicitly design the set of rules. You say, okay, if this, then we will do this, else we will do this. Right? So you study the system design document, and you say, okay, if these conditions are true, then we will do this, else we will do this. Let's say you're creating a web, a front end web application, right? A full stack application you're trying to create. So full stack, there is a front end, there is a back end. So the front end, you will write a specific set of rules to make the front end of the website behave exactly the way you want, right? So if you click on the button, this will happen. A button click event will be triggered. You write some JavaScript, right? All of you would have heard of HTML. It's a markup language. So you can design everything, every aspect of the website, right? So you can decide the background color, you can design the text, the formatting, the layout, and everything. So if you think about it, it's rule-based intelligence. It is not that the website is itself deciding how it should look like, but that has been hard coded. If you go to wikipedia.com, Wikipedia looks the same for you, it looks the same for me. Wikipedia has the same look and feel for everybody, right? And even if you look at backend programming, the backend development, which we do with Express.js, Node.js, and all that, even the ideas are very, very similar. You have explicitly hard coded what will happen. If you click on a button, something specific will be pulled from a backend database and it will be returned to you. Okay, let's say you're entering a form information. You're giving your username, password, and you click on submit. Something is happening. Okay, some information is getting pulled from the backend. So all that is design, all that is static thing. Okay, even inside the organization, if you're trying to design any applications, you will write the rules, you will write the code manually. There are tons of applications we see around us. Let's say we are all having mobile phones. Okay, we are all having mobile phones, and uh, the mobile phone, the workings of the mobile phone are governed by the operating system, the OS. You might have an Android OS or an iOS, whatever. Okay. Now, very interesting. If you keep your mobile phone in the sun for a long time, okay, so let's say in peak summer, in peak afternoon, you go out in the sun, you go to the terrace or go outside your office, and you keep your mobile phone directly under the sunlight for 5-10 minutes. You'll be surprised to see that after a while it gives a thermal heat warning. Okay, the mobile phone will actually stop functioning. And this is a feature that is built into the operating system. Because think about it, what is the operating system? The operating system is effectively a set of instructions. It's nothing but software, it's code. It's like hundreds of thousands of lines of code that are written, which govern how our smartphones are going to work, right? Everything from resource management, memory management, to even something as simple as battery saver. If your mobile phone goes below 15% battery, what happens? The battery saver mode is automatically enabled. And as part of the battery saver mode, you would have observed that the brightness of the device dims. And also, as part of the battery saver mode, the camera application, the flash does not work. So these are some of the things that happen whenever we start the battery saver mode. So the background typically dims, and also the flash of the camera application typically doesn't work. So these have already been hard coded into the system. And there are many, many other applications. You can think of the laptops where you're attending the session or you're listening to the video right now that we are in. And if you look at the functioning of the laptop, laptops also are governed by an operating system. And that is again a set of hard-coded rules. It is a set of if-else instructions that are governing exactly how the laptop will function under different circumstances. So if it goes out of battery, what will happen? If it goes to low battery, what will happen? Because sometimes when your laptop goes to low battery, you will see all your sync applications will stop. If you have OneDrive, if you have Google Drive, all those desktop sync applications will stop. Okay, so many of the background data tasks will automatically stop. Okay, even something as simple as not responding. Sometimes when you start a very powerful application in your laptop and your laptop doesn't have enough memory, you will oftentimes see that some of those very high memory consuming apps will go to not responding mode. So who is controlling that? Who is controlling that how much resources should be allocated to the different applications? All this is governed by static rules. Okay, static rules that we have hard coded, right? Now, and you can see countless examples around you. Okay, so if you have a car and if you go to your vehicle, the modern day automobiles are have many of these so-called static or rule-based AI components. Seat belt, if you don't put the seat belt, there's a seat belt alarm that will go, right? What is a seat belt alarm? It's like a simple if else statement that has been hard coded into the car. If it detects the seat belt is there, fine. If it detects the seat belt is not there, the alarm will start to beep. Okay, so it is like if seat belt, then no alarm. If no seat belt, then an alarm will start to beep. So that is how we can think of a seat belt alarm. Well, automatic headlights. If it detects that there is no light, the headlights will automatically come on. If it detects rain, automatically the wipers will come on, right? Or sometimes there is also automatic central locking. So you just come to the car, you start driving the car for 50, 100 meters. 50 meters, you start driving the car, and automatically the central locking will be done. And if you think of all these use cases, or maybe in the office spaces, you will have motion sensor based lights. Okay, so if there is nobody in the office, the lights will go off. And once you start entering the office, it will detect your movement and the lights will come on. Okay, and if it doesn't detect movement, the lights will come off. Or even something as simple as a revolving door or an automatic entry exit door that you see in office spaces, right? So if it detects motion, if the sensors will detect somebody is coming, the doors will open, and otherwise the doors will close. There is no rocket science in any of these applications if you think about it. If you think about any of these applications, they seem incredible. We take it for granted because they're a part of our day-to-day lives, right? We see a opening and closing of doors all day long. We are in office, but if you think about it, it's a pretty incredible system. So somebody has programmed it. Somebody has programmed how that motion sensor light is going to work. It's a computer program, and it is rule-based AI. The rules are hard-coded, and it is a simple if-else statement. It's a simple if-else conditional statement. If this, then I will do this, else I will do this. Somebody had to give that. Somebody had to give all those explicit conditions. Even something as simple as a coffee machine. You go to the coffee machine and you hit latte, something will happen. You press cappuccino, something will happen. Think about it. Isn't it incredible? Isn't it incredible that when you hit cappuccino, the machine understands how much of milk to add, how much of coffee to add, how much of frothing to do? Because typically cappuccinos have more frothing. No, I mean the frothing cycle is longer. Whereas if you do latte, it understands what happens in latte. Whereas if you do espresso, no milk is added. Isn't that incredible? Now, again, we take it for granted because it's part of day-to-day life and work that we do. But you press a button and the machine somehow knows, the agent somehow has the intelligence what it has to do. You go to your home and you will have to wash your clothes tomorrow. Let's say you go to your washing machine, put all of it in, and you hit a button called summer mode. I don't know, I'm just making it up. There's something called summer mode, let's say, or um, there is something called outdoor mode. All the top end machines come with different modes, right? You've got something called outdoor mode, sportswear, cotton mode, delicate mode, synthetic mode, steam mode. What is it? What is it? So you press a button and the machine magically understands what it has to do. How? How does it know that? Because the rules are hard coded. When you designed, the manufacturers of the washing machine have already hard coded the rules in terms of what they are supposed to do and what they aren't supposed to do. So if it is a cotton mode, the entire cycle is hard coded. That how much is the wash cycle, how much is the rinse cycle, how much detergent has to be taken, how much fabric conditioner has to be taken at the end of it. Everything is pre-programmed. You go to a assembly plant today, a typical manufacturing plant where you're manufacturing different automobiles, different types of products. Even a simple bottling plant, a water bottling plant where water bottles are manufactured, there are machines you see all around you, right? And when you look at each of these machines, which are performing very intricate tasks, even something simple as sealing a cap is quite incredible, isn't it? When you have a water bottle and you see that machine that is actually automatically sealing the cap and sealing that cola bottle, it's an incredible process. But can you think about who designed that machine? What is that machine doing? Is that machine able to figure out by itself how to do that task? No, it has been pre-programmed. And that's the way how we think of the term rule-based intelligence. But I want you to know one thing, that this is how AI evolved. This is how AI grew long back. Even today, we have a lot of devices which are based on static rules, but there are limitations. But there are limitations. And now we will talk a little bit about what those limitations are. Okay, so any kind of traditional software, you see the things around you today, a lot of it you can relate to as rule-based intelligence. There is no machine learning that is going on here. It's just simple intelligence. It's simple artificial intelligence that we have hard-coded. But there are limitations. Now, what are those limitations? What are the limitations of rule-based intelligence? What if the rules are not known? What if you're dealing with applications, especially in the world of unstructured data? When I say unstructured data, I mean to say images, audio, video, text, all this kind of data. Especially when we start discussing about unstructured data, what if the rules are unknown? What do you do in that case when the rules are not known, when we don't even know what the rules are? What do we do in that kind of a situation? Because now we cannot design an if-else statement, right? So what do I mean by this? What do I mean by this term that the rules are not known? So the best way to explain this, let me open up my photos, and I'm going to just take up a small example to highlight to you what I mean to say when I say that the rules are explicitly not defined. Let us see that for a minute. In the meantime, I'll bring up a small example for all of you here as well. So imagine that you have a task where you need to go through a picture, an image, and you have to predict what this picture is. Right? So let's say that's the task that we have. You have to go through this image and you have to predict what you see. I'm sure everybody in the class understands that this is called an elephant, right? All of you know that it's called an elephant. Now, the thing is, how do you know if you're trying to build an image classification model? How do you know, or what rules did you use in your mind to say that this is an elephant? How do you know, or what rules do you use in your mind to say that this is an elephant? So you can think of a series of rules, right? You can say that, hey, if I see if I see one trunk, two tusks, four legs, one big body, two eyes, then elephant, else not elephant. We can think about it from that perspective. We can think of that series of rules. If I see all these different things working in tandem, then it is an elephant, else it is not an elephant. But if you think about it, these rules are extremely hard. These rules are extremely hard. I mean, these rules work fine for the first elephant, but the rules do not work fine for the elephant at the back. Because if you think of this guy at the standing at the back somewhere here, the rules do not apply for this elephant, this other elephant. Why? Because for the elephant at the back, we cannot even see the legs, we cannot see the tail, we cannot see the eyes, ears, nothing, right? And make it, let me make it a little bit more complicated. Okay, so it's so difficult to hard code rules in these kinds of scenarios. If you look at this one, look at this. The tusk is such a defining feature of an elephant, right? But can you program it? Can you explicitly program and say that if there are two tusks, it's an elephant, else it is not an elephant? Can you pre-program the instruction? Actually, you cannot. You cannot explicitly hard code the instruction. Why? Because if you see the elephant at the back, this elephant has a single tusk. The first one on the foreground has two tusks, but the elephant at the back has a single tusk. And to make it even more difficult, look at this one. Look at this example. Look at this one. I don't think there's absolutely any doubt that this little elephant, this little guy here is an elephant, right? But there is no tusk. So if you think about it, images can be extremely complex. Even something which has a very defined structure like elephants, we all know what elephants look like, but we cannot hard code, we cannot write a script to identify elephants. That is what I'm getting at. We cannot explicitly write a script and where we say, hey, you know what, this qualifies as an elephant and this does not qualify as an elephant. Writing that script is impossible and very difficult. And look at these guys at the back. What script do I write for this one? I'm sure you're pretty certain that it's an elephant, right? I don't think there's any doubt about it. But even if you look at the pixels of the image, there is nothing that tells you that this is an elephant. There is no eyes, ears, nose, nothing. There are no legs. So even if you manage to write an if else statement, it will completely fail at detecting these kinds of objects. So in the real world, whenever you're working with unstructured data like images, audio, video, text, data which is complex, which cannot be defined or designed using simple rules, these kinds of data, we cannot write rules. We cannot use rule-based intelligence. And it is for this reason that we need something else called machine learning.